Hello everyone and welcome back to part 2 of our tutorial on Autodesk Inventor. In part 1 we created this little shell of our keyring thumb piano, and now we're going to make it look a bit more like a thumb piano, or a bit more like a piano at least. So what we'll do is we will create a little cutout here so we've got somewhere to play our keys. Before we start, I wanted to show you how to take the imperial settings of Inventor and how to fix them to metric, hopefully for good. But it's worth knowing this stuff because the way that large enterprise systems, particularly school systems, work is that they do revert settings quite a lot. So it's good to know how to change those settings to what you want. So here, I'll go through that again so you can see. We've got document settings, which we went to last time, and that showed us how to change these settings for that individual thing you're working on. Application options allows us to change things for the whole application, so all of Inventor. So if I go into File, we've now got our Configure Default Templates. So if I click Configure Default Templates, we can now select millimeters and International Standards Organization. Great. We'll click that. Do you want to overwrite? Yes. Yes, we definitely do want to overwrite. We are very happy with the metric system. Great. So we'll apply the settings and then we'll close that. Now, it's good to know how to do that because, as I said, sometimes systems revert back to their initial install. So what we need to do now is create our little cutout. So if I go into our body, what we can do, because we've returned to our assembly, we can go into on our browser on the side here and we can select Edit. And now we've got that part is available to be edited. So we'll go in here and we'll start a 2D sketch again, but rather than selecting our axes up here, we can just use the geometry we've already created. So we can use this section here, and that gives us a nice line perpendicular to where we want to create our extrusion. So I'll go in here and we'll create a spline and do it nice and low so we've got plenty of room for our keys to move. But again, as I said, this is Inventor, so you can change things later if you want to. Great, that sort of shape. Now I could come around and I could close that with a spline, but you can see that it's going to affect things. It's going to do some weird stuff with the top of that curve. So I'll just finish my spline there, and then I'll use a regular line to create the rest of that. There we go. I'll finish the sketch. Again, making sure that you do get that green marker on there, because that means that you are going to exactly the end of that line. Great, so we'll extrude that one. Now with this extrusion, because we've got existing geometry we're working with, we can actually use that as part of our extrusion as well. So I can change the direction here, and I can say, well, 10 millimeters obviously isn't far enough. I can say 35 millimeters, which would go to the other side. But it's always going to be 35 millimeters. So if I decide that later on, oh, actually 35 millimeters is far too small, I want to create something that's desktop size, I want to go up to 250 millimeters, then I won't have the same feature. It'll only go 35 millimeters in. But what I can do here, and I'll just change this back to 10 to demonstrate the point, is I can use one of these sections here. So I can say through all, which will go through everything. I can say I want it to go to a certain point. So say I want it to extrude actually to that face there and leave this side whole. Yep, I can do that. But I'm going to click to next, which will go to the other side of the part. And it's worth playing around with those and seeing what they do. I'll click OK, and now we have the cutout for our keys. It's very deep, but we can adjust that later if we need to. So now it's time to make our keys. So I'll return to our initial assembly, and I need to create a new part. So go to Assemble, Create, we'll call this one Keys, and we're going to the right folder and we're creating a standard IPT. Aha, I'm going to call this one Keys 2 because in the intervening time I have actually created another file called Keys. Excellent, okay, there we go. So now I've got to work out where I want my keys to be. I don't want them to be sitting right on the bottom here, or there'll be nowhere to press them for them to vibrate and create that lovely noise. So we'll create what we call a work plane. And a work plane is exactly what it sounds like. It's just like setting up a workbench at a certain height, and that's where you create your part. So we want to offset ours from an existing plane, again using the geometry we've created to work out where we're going to put our work plane. I've got this section here. Now I want to come up, I think 5 millimeters is probably a good height, and check that one. Yeah, 5 millimeters looks like it's a good height. Maybe a little bit more, maybe go 6 millimeters. Plenty of room to press down those keys and to get the nice vibration there, which will make them make the noise. So we'll click OK. And now we've got a work plane. Oh, I've created that in the body rather than in the next one, but that's okay. We can work from that. I do need to. That's interesting. I thought I'd created that part. Why have I not got that? We'll create it again. That's okay. We'll call this one Keys 3. I think because I started creating a work plane after I created the part itself. Great, so we've got our work plane in position. Now I want to use that as the basis for our keys. Here we go, Keys 3.1. It's now appeared down in our little file browser. This is one of those points where I'm just discovering the new software along with you. Great, we've got that. Now we go up to start our 2D sketch, as we do with every part, and I've got lots of different planes to choose from where I want to start it. I'll click this big one because that's the easiest one to work with. That's the one that we set up for the job. Now, I've got the option here to start with the geometry that I've already created. So if I go up here to Project Geometry, you can see that I've got all these different things that are highlighting. I can use the inside edge, the outside edge. I can also use this big plane down on the bottom, and that's offset from that edge a little bit by the radius that we created on the outside. I think I'll use that, as that is roughly the shape that I want to use. I will also pick up this edge here because I do want to go all the way to the outside edge. Now, if things do look a bit funny, it's probably just because of a bit of parallax. But if you go up here and you click top, then you get a nice view down. Now, what I want to do is bring that edge and that edge all the way out to here. So I can use our extend tool, similar to the trim tool, but it extends things instead of trimming them. And I seem to have done that a little bit early because it's not going to let me extend that, because this geometry is locked to the existing shape that's underneath it. So what I can do here is I can actually offset that, and I want to offset that curve. Now the curve I'm offsetting is this whole shape. So you can see here I've got a range in which I can offset that. Now I cannot offset beyond this point. Yeah, I'm trying to go too far. Here we go. So we're getting. Now I want this to be pretty close to that same size. So I might make it 0.1 millimeters smaller. Yeah, for all intents and purposes, it's the same size. Now if we go up here to extend again, and now we can extend that curve to this point here. Great. So we'll click that, click it again. The first extension is that 0.1 millimeters because it uses the next object it sees is only as far as it goes. And then I need to offset this one here by that same 0.1 millimeters. So extrude that in by 0.1. Excellent. And now if we zoom right in on that, we can see we've got a little bit of a crossover here, and we've got this extra line here. So what I can do is I'll just hit escape. If you're wondering how to exit any tool, you just hit escape. Sometimes it's worth hitting it a couple of times. If you're getting to the point where you're just not sure what's going on, just hit escape lots of times and you might find it cures your ills. We'll go in here to trim and we'll just get rid of these little tabs on the corners. And over here, we'll get rid of this one and this one. Great. And now we've got a shape that sits just inside here. So we'll finish that sketch. And if I go to extrude, I should be able to extrude that shape. It's offering me that as an option. It also should offer me the whole thing. That's what we want. Now the sheet metal that we want to work with for this is 1 millimeter. So I'll extrude this a distance of 1 millimeter. And we'll be able to cut out that metal on our water jet cutter here at the tech school. Great. So we've got our 1 millimeter thick steel, which is actually a lot thicker than our 0.7 millimeter wall housing, but that's okay. Now, our keys are here, but if you hit that, you'll just kind of get a dull thud noise rather than a dong. Someone's going to take that and remix it. So we need to create some keys on this. So what I'll do is we'll start another sketch based on our existing geometry that we've just created. And we'll start looking at some keys. I want our piano here to look like piano keys. So we'll start off here by projecting geometry. Yeah, let's project the geometry. We'll project this bit here, just that line. And we'll create a dimension based on that line. Great, so that's 30.8 millimeters. Now that's saying we'll over-constrain the sketch because what we're creating here is a dimension based on existing geometry. So the dimension that we create can't change what's there. It's just measuring it. It's just putting a measuring tape to a wall. It doesn't change the distance along the wall. That's okay, because all we need is that number. So the next thing I want to do here is create a number of keys. So I'm going to create a rectangle and we'll go from that corner point there and we'll bring that in. Now you want to be able to really hit a key with your big fingers. So let's say we'll make that 6 millimeters across. I put the wrong dimension in. That's 6 millimeters down. We'll make that one more like 12 millimeters high. Tab moves from one to the other. We'll make that 6 millimeters across. And we don't want sharp edges on our keys, so we'll come in here and we'll just add a little bit of a fillet. Let's say 1 millimeter. And we'll just add 1 millimeter fillet there and there. And now we've got a nice little shape. So how many of these keys can I fit into 30.8 millimeters? We'll find out. Exit out of that one. So what I can do now is I can do a pattern. I can pattern these keys along here. So if we go to pattern, there we go, back to where I was. I can first select the geometry, and that's already highlighted. So the geometry that I want to move is this one here. So that whole shape. And the direction I want to pattern it in. So I want to pattern it in this direction here. Now, and how many times and what's the distance? Now the distance is this dimension here. So what I can do is I can actually just click that dimension. It's D4, I'll just get rid of this bit here. So this dimension is, as far as the software is concerned, is D4. So I can actually delete everything that's in there and just click that and that'll give you that dimension there. Again, if anything changes in the future, it'll change based on that dimension there. So my keys that are now 30.8 millimeters from end to end will be whatever size. If I change up to 250 millimeters, then there'll be that 240 odd millimeters along. Now, how many keys do I want? I've got 2 keys here. I think I might go 4 keys. We can go in here and click OK. And in direction 2, we're not using direction 2. Direction 2 is only if you want to do a full rectangular pattern. We only want to do a linear pattern. So we'll click OK. Now, I've made a mistake. I've created them 30.8 millimeters between each one, rather than fitting them into that 30.8 millimeters. So what I can do is click on my first part here, and then I can go to, I should be able to edit that pattern. Edit pattern, there we go, it's sitting there as a button right there for me. So what I can do now is make them D4, make them that. So I can, there's here associative or fitted. So if I click fitted, then we're looking at fitting them into that dimension. So we'll click OK and see how we end up. It's now, okay. What it's done is it's given it to me edge to edge. That's okay, so we go back and we can edit our pattern again. Go in here, if we change associative and see if that makes a difference for us. Not quite. Again, it's not a problem. All you have to do, the great thing about Inventor is that everything is editable in the future, which is nice. So I go back to this line. Now I've lost that button, but it should be up here somewhere. Oh dear. What has happened? I just have to keep going and edit this one back in. Inventor 2020, what have you done to me? All right, and we'll cut from before and start from now. Oh dear, there we go. So what it's done for me is it's created those parts 30.8 millimeters apart, rather than fitting them into 30.8 millimeters. So if I go down here, I can select fitted, and now you can see that they've fitted edge to edge in that 30.8 millimeters. Now it looks like that if I'm trying to fit all those parts in, the gaps between them are just going to be a little bit too small. But what we can do here is we can really test that by saying, okay, we want them to be fitted edge to edge in 30.8 millimeters, but actually I want them to fit into that distance minus the width of the last key, which is 6 millimeters. Or if I'm being really clever about this, I can actually select that dimension there. And now we've got them fitting right into here. So it's measuring from this edge to that edge, fitting them into a shape that is this dimension minus that dimension, which gives us the exact distance that we want. So if I click OK on that, that didn't work. Blast. Cut. Start again. What it's done is it's created a pattern with the pieces too far apart. They're 30.8 millimeters from each edge, rather than fitting them into that 30.8 millimeters. That's okay, because in Inventor you can always go back and edit things. So we'll select our geometry and we'll select edit pattern. And now what we can do is say that I want them to fit fitted rather than associative, or as well as associative. I can do both. And then I can say is the dimension is, instead of going common edge to common edge, I want it to fit into that dimension minus the width of the keys, D6 there. And so that's all good. We'll click OK. And now we've got our keys set into the right shape. Excellent. Now all these keys are based on that first dimension, and it looks like they're a little bit too deep here to really get a decent amount of vibration on that first key. So if we come in here and we change that down to say 6 millimeters, because I really do need some room there, it changes the dimensions of all the keys. Great. So we've now got a decent amount of room here to create some a little tab. Now we can save this sketch at this point. That's right, you can't save during sketches. So we'll have to finish that sketch, and then we'll have to save. And then we'll come back and we'll edit that sketch and create a thingamabob. It doesn't really matter because I'll do that. Now we've got our keys that look like they're pretty good to be able to press. We need to create the actual arms they'll sit on that'll vibrate and create the sound. So what we'll do is we need to again reference some geometry, and to that we'll go back into our sketch. So I'll go into here, we'll go edit sketch, and now we've got back to the same place we're on. We'll project our geometry here, and this time I want a decent offset from that geometry to give us a good rim to get that soundboard sort of effect happening. So we'll offset this by a pretty solid amount. I think I'll say in this case 3 millimeters. I also now need to think about how we're going to mount our soundboard with our keys on it to the body of our piano. So I need to put probably a couple of holes in. I'll put in some little posts and we can screw that down. So I need to think about that at this stage, and what I'll do is I will create some little circular sections here. So let's use the circle tool. And they need to be sort of fairly arbitrary positions between keys. So here I'm going to say that I'll make that one 6 millimeters across, and we'll make this one down here using our lines to line it up. Again, about that sort of 6 millimeters across. Great. So we've now got something to screw them down to. That one I think we'll move down a little bit, just to there, and we've got that one there, which will move to here. Great. It doesn't matter if they overlap that a little bit, they're just sort of geometry to work around and to guide us as we create our little vibration arms for our keys. I'm sure there's proper terminology for this, I just don't know it. Now we've got our rough position of our mounting holes, we can start positioning where our little arms are going to be. So we'll bring that one up to here. Again, starting in the middle, you notice that it started off with that green dot, and that green dot indicates that we're in the middle of that piece. The length here I've got set to, let's go, there we go. So in this case it's a fairly arbitrary number here, 9.319, but the important thing is it's 0 degrees. 0 degrees means that it's facing directly up and down. If it's not in relation to anything else, the degrees is always 0 is up and down, 180 is down, 90 is to the right, and 270 is off to the left. Although in this case it's giving us 90 degrees to that one because it's going a relative geometry. The things you learn. So in this case, I can't get it to that line. It's not giving me anything to select there. So what I can do is actually go well past that line, again making sure that I've got 0 degrees, and if I need to I can go tab and make that 0. And then, oh, that didn't work. Why didn't that work? Or did it? No, I didn't get a line out of that one. That's interesting. So I'll say call it 50, tab 0, enter. There we go. And now it's giving me a line that's far too long. I can delete that 50, and now I've just got a line that's 0 degrees from there. And I'll continue that process along for all the keys. Again, starting in the middle, going up, again, deleting that dimension. The reason I'm deleting that dimension as we go is because I don't want it to constrain us in the future. I just want it to constrain it for the actual construction of the line. So we'll do our last one. We've got 50 millimeters at 0 degrees. And once it's created, I can remove those dimensions. Great, so what I've got now is a center line for each one of those keys. And you can see here that our top mounting circle is in the wrong place really. It needs to be between the two, so it can go there. This one looks pretty good where that is. What I need to do now is give these lines some width and create a shape that we can cut out. Now, I want them to be fairly thin because I do want a lot of vibration out of these, which gives us the sound of that of each key. So the first thing I'll do is, to avoid confusion, I'll trim them down to our little 3mm line there. Again, that's 2 clicks, because what I need to do is, in fact, there's another way I can do this, but what it means is that by trimming out that section there between the 2 lines, and then hit escape to exit the tool, and then I can just select these lines one by one and delete them. That'll just help us avoid any extra stuff, because when you start putting dimensions on, if you've got extraneous geometry, stuff that you just don't need, it can get in the way. Now we need to offset these either side, and that'll give us a good position to start with. Now I said I do want these to be quite thin, so we're going to go with a 0.5mm offset either side, and that will give me a 1mm key. Now since the last thing, let's go that one, yeah, 0.5, there we go. So do that for all those keys. Can offset beyond that point because I've selected the wrong one. There are some keyboard shortcuts, so you can go up here and you can select offset, escape out of that one, or you can also hit O on the keyboard, and that does the same thing. So I want to offset now. This is one of those ones that I set as a length and dimension. So there's this little line here that says, now that says this line is locked to something else. So I can actually delete that little symbol, and now all it's telling me is that it's parallel to that line there, which is fine, and I should be able to offset that one. So if you find that a tool isn't working, it's probably because there's a constraint that you might need to deal with. So I'll delete that constraint there. And we'll give that one a go. That's interesting. This is one of those new, there's a bit of that. I think that was that initial line that I made that got created as a construction line rather than an actual line, and that was why, again, another thing that you'll definitely come across, and that your students will absolutely come across. And as you're aware, if there's a problem in a program or in the way something that works, your students will absolutely find that. So if we go in here and we'll offset, we'll try this the third time. Hopefully we've got rid of all our problems. Excellent, we've got that all sorted. 0.5, and we'll come out this side, 0.5. Ooh, I think I'm going to just do a quick Control Z because I think I offset that line into the middle of this one. This one's really giving us a feast of learning. Offset this line, here we go, 0.5. Great. Now with any luck, this line will be easier to deal with. It's continuing the theme of offering us all sorts of constraints that seem to be new and default settings in this new Inventor 2021. They do have their uses, but in this particular application they seem to be slowing us down rather than speeding us up. Sometimes it's a bit like Microsoft trying to be helpful versus Google trying to be helpful. Right, so we've now got our little arms that will vibrate for each key. Musically, I have no idea how these will work, but we'll find out. So what we need to do now is create a soundboard out of each one of these. So I need to join up all these curves and trim the ones that I don't need. So I'll extend that one, and I'll extend, let me extend that line, probably not, that's okay, I can deal with that one later. And we'll extend that one, and that one, and now we need to do some trimming. Remember, what we're trying to create here is a full shape that we can extrude, and then we'll be able to take that shape into our water jet cutter, and we'll be able to create a soundboard from that one. I've also got this line here. Now, rather than deleting these lines, I'm going to turn them into a construction line, which means that they won't be a geometry that will affect anything, but I'll be able to use them as a reference for future things. So they've turned into dotted lines, and we've now got something that looks pretty close to what we need to extrude, but we've still got a few extra little bits we just need to trim off, like that bit there, and that bit there. This one, okay. So we've now got something that's looking pretty good. I need to trim out that section there, that section, that and that. You'll note that we don't have screw holes in those yet. We'll do those in just a second. I don't have a back to this line. That's okay. We'll come in here and we'll offset that in by 0.1 millimeters. And now we can just use our line tool just to fill in the gaps. So go from our green dot here to our green dot there, zoom right in, make sure we've got the one, and that we haven't selected our other projected geometry. And you've got two things that are close together, it can lead to a bit of a mistake. Great. Now this line here, this section doesn't really need to exist. So what I can do is I can come in and I can extend that line. Now you note that this is what I mean. We've gone to our projected geometry rather than the one that we want. So we'll just click again, and that gets us to that one. And now we can just come in and trim away the excess. And we'll delete those little standalone lines. Excellent. Still got some sharp edges, which we can get rid of with our little fillet tool. And we'll just get rid of that one. Don't like sharp edges. That's That's a spline. We'll have to do that later. That's okay, we can do that. But we can get rid of some of these ones in here. So let me do that one and that. No, because that's a spline as well. Of course it is. That's okay, we'll do that when it's in 3 dimensions. We do have some sharp edges there though, which, look, we're doing stuff in 3 dimensions anyway. Let's do that. So I finished the sketch, and now we've got this shape on that shape. Now you might be asking, why don't we just create this shape to begin with, rather than creating a big pattern and then cutting the other one out? And that's because the big one we created at the start gives us the boundaries for where we're going to work. So I can click extrude here, and I should be able to click that, and that shape. And what that gives us is it's saying it wants to initially extrude that up. So we'll extrude that down to next. Now we're into what's called these Boolean operations. Now these are mathematical operations to work out how something is extruded. You can join it, in which case really not much changes in terms of the shape. We can cut it out and you're left with the things that are sort of apart from that. Or what you can do is you can intersect it. And what that means is that the shape that you're extruding, only what's in the intersection between the shape you're extruding and the shape you're extruding into is left, in which case it's our little soundboard for our keys here, which is great. So we'll click OK. Now the reason I didn't put those screw holes into our initial extrusion is that we're going to use the hole tool now to create those. And the reason we use the hole tool is that creates another feature that we can then edit later. So I'll start another sketch once again on our existing geometry. In this case, I just want to project the geometry of that circle there and that circle there. And you note that they come with these nice little center points, which we might be able to use, but I'll use our point tool to put those points on just in case the hole tool doesn't pick those up. We can finish that sketch, and what we've created here is another sketch layer, sketch 3 in this case. Probably should name these as to what they are, and then we can go up here to hole tool. Now our hole tool gives us a heap of options rather than just a straight hole. So if we wanted to create a tapped hole, for instance, a hole with a thread in it, we can select any number of threads, metric or imperial, or even things like British Standard pipe thread. So if you're creating anything with existing pipes, you can both do tapered pipe thread and regular pipe thread as well. We don't want that, we want metric. If we were to go metric, and I actually just want a plain hole. Just letting you know that is an option. You can also do things like countersunk holes, where you can create those. This is particularly good in 3D printed parts, but for our simple part, we're just going to go with a regular hole. But this is why we use a hole tool rather than just using that as part of our extrusion. Our hole is going to go to, and now what we can do is select the surface. If I go through all, then it might actually go through our next part of our assembly. So I want to select a surface, and I can go to the underside here, and I should be able to select that surface there. It's telling me it's coming up with, right, coming up with a couple of issues, so we'll just do a measured hole in this case. And it's because I've still got it set to a, there we go. I still had it set to countersink. Now, if we go to measure depth, we just want to make, that's width of hole. Width of hole, I think I'll leave at 4 millimeters. And then we'll make this one 1 millimeter because we're only going through our initial part. It also gives you the standard drill point to the bottom of your hole. If you can select a flat point or a drill point, and that's just to better represent real world operations that will happen to your part. Great, so we'll click OK and we'll return to our assembly. But first I'm going to get into our little key section here with the filleting tool and take off some of those sharp edges. So we'll start off here and we'll go edit, so edit the part and make that available for getting in there and getting rid of some of those sharp edges that we don't want really on anything. Now, because this is mostly going to be contained, I don't want to take away too much, so I'm going to go with a 0.5mm radius. And that allows me to get a good curve, just enough to stop it being a nuisance. And I'll just go around pretty much everything with that 0.5mm radius. And that'll get me a stronger bond, and also means that the water jet, when it cuts these out, isn't trying to do a sharp corner, which can sometimes lead to the jet actually running on a little bit, and it might cut through a bit more of our thin 1mm little arms there, and we want to keep those as precise as possible. So we'll get down into here and get all these little parts, we'll get in there, and myself lost a little bit. Do a few of these that I can see from one position rather than having to move the camera position around too much, and because I don't want to make you all seasick. And get the last one. Great. Make sure I've got all those radiuses. I do, and we'll apply those, and we'll exit out of that tool. Great. So now I've got our keys all nice and filleted. Now we'll return to that one. So the first thing I'll do is I'll create the posts that join our keys to our body. And to do that, I will go into our body, and we'll edit this part. So go edit, and we want to create a new sketch. So start 2D sketch, and we'll start from this base plane here. That's actually exactly where we want to go from. And once again, similar to the other parts we created, we're going to project the geometry. So I need to project that part there, and I want to project that part of the geometry. Just the two parts of the holes. Now, because we created those holes using a hole feature, and this geometry is linked to that, if we change the size of our hole feature, it will change the size of this geometry, and it will change everything else. Again, the wonderful thing about parametric CAD, it just saves update work when you make changes. It's a really great way to design stuff. So we've got those two. We will now offset that geometry, and I'm going to offset that in by quite a way. So I'll offset that in by, let's say, what do I make that? Was a 4mm hole, I believe. So 1.9. So just gives us a teeny tiny little hole in the middle. I'll do the same thing here. And we'll be creating another hole feature. But what this means is that it gets, and I'll do the outside as well, it gives me an opportunity to use that hole feature rather than trying to guess any sort of geometry there. So for the outside, I will go out by, I want something pretty solid. I want to be able to actually have some material to go into here. So I might go 1.5mm out from each one. So 1.5. And then I've got my, my geometry here, which I can then extrude up. So I'll finish that sketch. We'll go to extrude, and we'll select that, and also the inside. Same with this one, might do this one the way around. Now I want to extrude that again. It's saying 10 millimeters because I think that's the last thing that I extruded. We'll extrude 2 next. And we'll change the direction of that. Okay, so 2 next in this case is extruding within the part, it looks like. That's all right. So what we can do then is say extrude 2, and we can select a face. So we'll select our face, make sure I've got that selected, and I want to extrude to this face here. Great. So I've now got my, my 2 posts built into my part there, and we'll click OK. Now I need to have some hole to put some screws in, so I will go up to Start New Sketch, and this time we'll start from the top of that part there and project the geometry. Now it doesn't matter which one of these circles that I select, because they're all concentric. So I'll actually select that outside one to make it nice and big and easy to see. And we'll select that one there, that one there. Grab my points in. So those points for the center of those circles. And again, that's so we can create a hole feature for that. Great. So we'll use our hole tool, and this time I want to create a smaller hole. I think I will create a 3.7 millimeter hole, and oh wait, no, 3.2 millimeter hole, because I'll actually try and thread these with a tap and get those in there. So look, we can try this with a tapped hole and see what happens. Because it's a there we go. Because we're 3D printing this, I'm not entirely sure how this is going to work. But the lovely thing about 3D printing and this whole CAD design process is if it doesn't work, you haven't actually wasted a lot of time, and you can always come back and edit stuff. We'll give this one a go anyway. Let's change that to isometric profile. I selected the wrong one before. And I want that depth to be 5 millimeters. And come over here. So that's the threaded portion I want to be 5 millimeters. And I want this to be 5 millimeters as well. So you can select a portion that's going to be threaded and a portion that is going to be unthreaded. Excellent. So we can give that a go. It does look like I've got a width on there. That's because it's saying size 7 millimeters. And I want to change that size down to 3 millimeters, because I'm going to go for an M3 hole if I can. Designation here is M3 by 0.5. So if we were doing that as a regular hole we were going to tap, we would make that 2.5, because you go for the size of metric thread that you want, minus the size, minus the pitch. And that's a good rule of thumb for making the right size holes. Once again, I should change those back because it's gone to the default settings. Okay, so now we've got a metric 3 threaded hole with that's 5 millimeters deep, and all 5 millimeters of that are threaded. So we'll click OK on that one. And here you can see the inside of that hole, and it's offered me threads. I'm pretty keen to see how that goes when we try and 3D print that, and see if we can actually get a thread M3 screw through to thread in there. That'll be fun to find out. Now what I need to do is smooth that interface a bit. It's a very sharp edge down there, and as any engineer will tell you, a sharp edge is a stress riser, and that's where you're going to see a failure. So I'll make that radius probably just 1 millimeter will be fine for this one. That one there. That one there. And we'll apply that. There we go. And now our posts are blended nicely into the base there. And we should still get some nice vibration transmitted through to that base, which means more noise. Excellent. So we've got something that looks a bit like a piano. We've got keys. I'll just return to the assembly here. So you can see the keys, you can see the piano-ish shape, but our grand piano doesn't have a lid, and we do want a lid. I think it'd be really cute if the lid were to fold up on the edge as a grand piano does. So we'll do that next. We need to create a new part. In this case, we'll call this the lid, and just a standard part, and saving in the right folder, and we'll click OK. Now I want to start that part really from this point here. Excellent. Start a sketch. Just on, there we go, on that edge there. And again, we'll just use the geometry that we've got already to start our lid. Great, and then we'll use that line there. And I might leave that line off because I'll extend this other line in to create that, that point. So now all I need to do is do my offset. And again, I'll try and offset outwards. Yeah, I can offset outwards, that's good. By 0.1 millimeters, because I want to keep this, fairly similar to the size. And now we can just use that extend tool, hopefully, and that will get us, there we go, that will close up our shape. Oh, not quite. So we can extend it just again and extend this one, and now we've got that closed up shape. Fantastic. Finish that sketch. And now we can extrude our lid. The lid, I think I will make that same 0.75 millimeters. Great. So we've now got our lid for our grand piano. But we need that lid to be able to open and close, really to get the screws in there as well. So we need to make some hinges on this side, and we can 3D print those into the structure itself. So I'll return to our main assembly, and I think I will, I think I'll put some hinges up the side here. I might just do one big hinge that sort of goes along here. Try and keep it nice and sturdy. So we're going to edit our body, because that's the part we want to change. And now I want to create a sketch that sort of comes out from this face, and then we'll profile that. So I'll start off by starting a sketch on this face here. Now we may not have to extrude any geometry here, we may be able to just use our rectangle tool. There we go. See, it's highlighted that line. Great, so that's the geometry that we're referencing. And I'll come down to here. Now really, the measurements here aren't important. So I'm going to make this any random measurement. That looks about right. Let's go here. And we'll finish that sketch. Extrude that out. Now I'm going to leave that extruded quite a distance, because we're now going to come in here and start a second sketch. And this is where we create the cut profile for our prism. Now while I could have created a sketch, I could have created a work plane at that point, there are ways to do that. This is just an easier way to do it, particularly for students. So I'll come here, we'll draw a line. Now, the angle of this line, since we're 3D printing it, is fairly important. Really, the most we want to go is 45 degrees, which means we can print that without support material. But if I come in here to really, pretty close to let's say 75 degrees. So I go tab 75. And now we can make that a little bit longer. I'm going to go quite long with this one because again, what we're doing is creating a cutting profile. So I finished that sketch a little bit early. I've got to get back in there and turn that into a cut profile. So into our body, this is where naming things gets really useful. So I'm going to start naming stuff. We'll call this one the hinge. So I'm going to rename, there should be a tool there. Oh dear. It's one of those things they've changed in 2021. Here we go, we'll call this hinge. And sketch one we'll call cut profile. Now I'm not going to name everything because that would take too long, but you get the idea of where knowing what stuff is really helpful. So we'll come in and edit this sketch again. And we'll draw a line from here. Again, using our little green dots to make sure we've got the right bit. And we're up to that point there. And we'll finish that sketch. And now we can extrude our face back this way. And you can see that what we've got left is the angle that we want for our hinge. Click OK. And now I want to start a sketch. And I'll start the sketch here. Because I now need to create the vertical part of the hinge, the lid will actually, where the hinge hole will be. So I'll come up here and we'll go a rectangle from here. Hinge barrel, that's the term I was after. Great, so I've got that profile there. Start the sketch, extrude, and I really want that to be probably no more than 2 millimeters high. How does that fit with our lid? 2 is even probably a little bit too tall. Let's make that on 0.2. So we're dealing with really quite precise measurements here, 0.2 of a millimeter. Great. So I've now got what will form the hinge barrel. Now this, I could create another cut profile to round that off, but I'll just use our fillet tool and 1 millimeter is far too big, so we'll make that 0.45 millimeters, just so we've got just a little bit less than the total width. There we go, and we'll apply that one. Now I do want to blend that into there, so again we'll use our fillet tool, move that around, and we'll blend that one, that one, that one, and look, I think, how's that? I don't really want to blend that, I don't think so. I do need that more of that face to work with. So I'll quickly cancel that one and we'll go back to it. If you do stuff that you want to do, so I know I want to do those 3, I can then click apply and I can keep using that tool. So if I do that one, say, and that's taking up a little bit too much of that face for my liking, so now I've applied that to the other ones, I can make that a 0.2 millimeter and that gives me more of this face to work with. Alright, so I've inserted a couple of holes here, same way we've done all the other holes in the project so far, so I wasn't going to bore you with that bit. We now just need to create the last little bit of our hinge and then we'll be ready for manufacture. So I will start by selecting our lid here and we'll edit that. And now I can project, start a new sketch. This should all be fairly familiar by now. Project that geometry and this one over here. Great. Now that is sitting right on that line, so we'll offset that one over a little bit. Let's make that 1 millimeter across. And over this side we'll do 1 millimeter across. And that gives us a nice little point where we can select that, draw a rectangle. And what we're going to do with this rectangle is just extend our lid out a little bit so we've got somewhere to create a little barrel for our hinge. So let's finish that one, extrude out, and extrude out that way. We want to only go out probably 2 millimeters. How big is 2 millimeters? 2 millimeters will do. Probably a bit too far. Let's look at 1.5. Yeah, 1.5 works quite well. Now, that's a little bit narrow still for me to be able to get a hole through. So what I'll do is we'll actually start another sketch and we'll project the same geometry. So come down here, project all that geometry, and I can draw a line. Actually, I can just do this rectangles. Nice and easy there. And we can also do that on this corner. And extrude those up. Now, doing everything just by eye at this point. 1.5, look, that's probably okay. Might go down to just an extra millimeter. Oop. 1 millimeter, not 11. Very important. And now we can use our fillet tool to get some nice curves there. Ooh, that's quite a nice one. I like that 2 millimeter fillet on that one. That's good. We'll apply that. And then we'll apply smaller ones to the rest. So make those 0.5. There. There. And under here. And over this way. And we've also got the opportunity here to add one on this end and on here. There we go. Smooth everything right out. And do the same thing here. What's going on there? Occasionally the fillet tool doesn't play nice, but that's all right. It's only a keyring after all. Oh, there we go. That turned it out okay. And now we can, there's two different ways of doing this. We can either put a little pin, create a little pin from the inside of this part here to go across, or we can put a hole that goes all the way through everything and put a big sort of nail or metal pin in from the end. I think I might try for putting a metal pin in because we're dealing with some quite small dimensions here. So what I'll do is, you guessed it, start a new sketch. And in this case, we're going to project the geometry of that hole. And we might do this one at a time just to make things easier. Yep. Going to extrude back this way. And we can afford to be a little bit rough here because we're right at the end of the project. So it's going to come all the way out the end. And we're happy with that. And then we'll come down here and do the same process again. And that will give us a somewhere to put a little metal rod to create that hinge. Project geometry. Oh, I projected the wrong geometry. So this brings the CAD sessions to an end. And now we'll be looking at actually creating these parts using computer-aided manufacturing, or CAM. So to do that, we will 3D print. Yep, that's okay, that's interesting. I'll sort that one out later. So to this, we'll 3D print this section here, and we'll 3D print the lid, and we'll either laser cut or waterjet cut the keys from different materials and see how they go. So I'll see you in the next session in real life.